So I could write programming code to... Programming code?
Hey, Matt.
Hey, Mike.
Hey, would you like to do a podcast?
Yes.
Perhaps one that continues from a previous one in content?
That's an advanced concept you got there, Mike.
Oh, well, I'm going to bring my basic primitive ideas and we're going to put them into a goulash and make something complicated out of it. Hello and welcome to Hacking the Grepson. Today we're doing part 2 of a 2-part episode series on data types and structures, which is a very foundational concept in programming and development. You know, before you can start doing cool things with computers, you kind of have to know how they represent data and how you can represent it. And last time, on part 1, we talked about basic primitive variables. And just to quickly sum up what those were, there was the Boolean variable type, which is essentially a binary value, i.e. it's either true or false, 1 or 0. We went over numbers, which represent a single numerical value, be they an integer, 1, 2, 3, or negative 1, 2, 3, or 0, or a floating point, which means it's like 1.5, 2.3, something like that. We also talked about strings and characters. Generally, people work with strings, which is an array or collection of characters, like FOO or BAR, usually in quotes. A character, it would be just a single one of those. Older programming languages have that as their own data type. Nowadays, we generally just deal with strings. Characters would just be like a one-element string. And then we also talked about pointers, which are like variables, except instead of returning the data, they return the actual memory address where that data would be. So you could have a variable pointing to the string variable mat, but then you would have a pointer variable pointing to the memory address where that is in memory. Today, we're going to go over complex variables, which are generally those primitive types, but put together in a scaffolding or structure that makes them a lot more easy and flexible to use. Because if everything you did was in primitive types, you'd have to do a lot more coding and it would be hard to make more complicated programs, I think. But Matt, I've been talking for a while now. Why don't you jump us into the very first complex variable type?
So the first one we want to talk about is an array, or it's also sometimes referred to as a list. This is arguably, this could be put in the primitives section, but I think it makes sense to put here in complex. But it's right on that line, because you mentioned, what if you had to write everything in primitives? Well, basically, when I was writing in C, that was what we were doing. There were not most of these complex types, except for like one other one in here. It was basically arrays and one other thing that we'll cover in a little bit, which is structs, which were basically just syntactical sugar on top of the basic pointer arithmetic.
Ooh, I love that you brought up that term, because I do like that term, but could you define what syntactical sugar means?
I can sure try.
Tell us the sweet definition.
Yeah. Feel free to jump in with corrections on this.
Okay.
Syntactical sugar is basically a way of saying that the language gives you a nice way of defining something. Basically, it's a shortcut. It's the way I usually look at it. The syntax, right, the way that the language is written, has some sugar, which is a nice to have. That ultimately is just it's quality of life thing is the way I look at them.
Yeah.
You can have an array in C by saying, here is my pointer, and I know that they're going to be integers, so I could write programming code to I can write programming code to iterate over each number, increase my pointer by 4 bytes each time, and I know this is a 32-bit number, and I'm going to interpret it this way, and or I could just do bracket 1, and it goes to the second one, right? And it's the nice thing that the compiler provides you. It's a nicer way of doing something that might otherwise be more difficult.
So it's like Yeah, it's a further abstraction from the kind of default, not default. I mean, it's weird when you said it that way. You made me think that like all complex variables are just syntactical sugar
I mean, basically, it well. So where
in
that
a
gets
way.
weird is there are languages, Python as an example, where the whole thing is basically that, right? White space has meaning. You don't have to write begin and end. You don't need semicolon. Like the whole thing is that. But I guess it would be. It's probably like I'm used to X, and now I've got a nice way of doing that instead.
I mean, isn't anything that isn't 01 syntactical sugar? I went there
Uh, I'm not going to argue with it,
because
mostly because I don't know what the formal definition of syntactical sugar is.
I think one of the first time I ever heard that term was probably when I was doing Ruby or something like that, just because Ruby tends to be known as an expressive language where you can write less but mean more. Ooh, I just came up with that, I think, or I stole that from something I read once. I feel like that's a good definition. It's a way
Yeah.
to write more, get more by writing less. Something that's less. It's not wordy is not the right word, but just
So the actual definition, which I think is very close to what you're saying, I just looked it up, is syntax within a programming language is within a programming language that is designed to make things easier to read or to express. So you've got a complex concept, and now you've got this easy way to say that's what this means, right? Like the at property tag, like does a whole bunch of stuff behind the scenes, and you're just representing it with this one little thing.
yeah. A one that I probably use constantly are in JavaScript array methods, specifically like map and filter and sum and every, because you could just write everything as a for loop, like a basic for loop, which goes through every single element in an array, checks for a condition, and then does something. Or you could use the syntactical sugar of dot filter or dot map, which essentially does all that kind of stuff, but in a slicker, streamlined way.
We're getting way off topic,
We
but
really are.
like a good
But
example of
arrays are
syntactic
so
sugar.
interesting, you know.
A good example of syntactic sugar that I will tie back into lists is Python has this concept of list comprehension, right? It also has uh, ma- dictionary comprehension as well, but that's way more complicated. But basically, I could say, oh, I've already got a lot of information elsewhere, and I could basically write my list constructor as a for loop inside of the bracket. So it's just syntax to say like bracket for I is 1 to 10 I, right? And
Right.
but I put it all inside and the close brackets, and then I get an array that is 1 through 10. So
Right.
an array is just to go back to definitions. It's just a collection of values, right? It's
That's all it is, man. It's no big deal.
and a list is another term for the same thing, but an array typically the difference to me is if you tell me something is an array, I am going to interpret that as the data is all the same type. Like it's all integers, it's all characters,
it does not have to
or
be.
it's all objects, but
Right.
it doesn't have to be. But when you talk about an array, I view it as that, and that data internally is represented as a contiguous block of memory. And a lot of that would have to do with access. Whereas a list is very, very, very similar to what I just said, except I think it's a little bit freer, right? There's an abstraction there where I say I've got a list of data, and all that really means is there's an order, right? This value comes before this value, which comes before that value, right? So you can represent like you can represent the numbers 1, 2, 3, 4, 5 as a list, and I know if I go to the second element in that array or list, it's going to be the number 2, right? As opposed to you could just have a jumble of data and randomly access it. But being able to specifically index into that array, I think, is a huge part of what makes something an array or a list.
Yeah, I think just to use this as a segue into well, can you just talk about the second one on this list too, just because it's so similar?
Yeah,
And
sure.
Then I'll segue into another one.
Yeah, the more complicated ones.
Sure.
Yeah, another thing that is like an array or list, and you would typically access this. I would say, in general, you would not access a set, which is this other type. You wouldn't necessarily index into it. It's a collection of data that it's a feature of a set is that it only has one of any value, right? So it's a good way of collecting things. If I don't care how many of them there are, I just need to know which ones are there and which ones aren't.
Right.
So like if you're taking attendance, right? The order of people doesn't matter, but the fact that I accidentally counted Mike twice also doesn't mean that there's an extra person in the class. I'm like, yes, that person's there. Put them in the set, put them in the set, put them in the set. Now I've got a set. This is the set of people here.
Right.
And you can keep, Mike is in that set. Yes. And Mike is in that set. Yes. And Mike is in that set. Yes. Right. But there's still only one Mike. Whereas if you do that to the array, you could say like, oh, there's 3 Mikes in this array.
Yeah. Isn't it weird how when you start talking about a thing that you understand, but when you try to think of an example, it's like impossible to think of like a real practical example. And I'm like thinking, oh yeah, well, what if I start to, randomly duplicate in that classroom, and so my name comes up twice? You don't want to count me twice because that happens a lot with people randomly duplicating. No, it doesn't.
Most of the time when I'm using sets, it's in things like the, programming challenges.
Right.
Because that's where it's got I need some weird clever edge case where I'm like, oh, I need to know that this person walked in this hallway ever.
Right. Well, it's like, but you don't need to know how many times they did it. You just need to know that they ever did it. And so that's why if you do a report on all of the events, you just want to get the event types, not the event counts. And thus an array would have both, whereas a set would just have the distinct event types.
Yeah. A nice feature of sets is that there is a set, I want to say it's called set arithmetic, which is basically, add 2 sets together, combine them, form a union of them. And so if I have 1, 2, 3 and 3, 4, 5, and I join those, okay, 1, 2, 3, 4, 5, even though 3 was in there twice, right?
Right.
And then similarly finding a difference, finding things that are only in both. There's the ands, the ors, and the XORs, basically, to go back to like really logical operations. And that's the main place where I've used sets, is when I'm trying to when I'm trying to form logic operations. And I don't just mean and or, I mean like actual logic, like primitive logic. I can't think of it. Predicate logic on data of some sort. I'll tend to use a set for that.
Yeah. I also think about this. I don't think about sets when I'm doing this, but when I use SQL or some kind of database language, they have a lot of like disparate data sources that you're trying to join together and get like one master list. And often you'll have duplicates and you want to remove the duplicates. And I assume there's some kind of set logic that you can put in there, but I never think about it in those terms. I think about it more in just like getting a report and making sure I only get distinct types. But yeah, the sets, I mean, I don't do them a lot, but I assume, like I said, if you were doing database programming, you'd probably use that concept a lot more. Okay, so arrays, just a further point about them. They are a collection of values. They could all be the same type, like all like 1, 2, 3. They could be all characters, like A, B, C. They could be a disjointed thing where it's like 1, A, true. That would be kind of rare. And generally, that's something you would see more in in JavaScript, an object. And so I'm going to jump to object, which I feel like some of the other types here kind of overlap with that. But it's something I'm more familiar with, so I'm taking executive powers and jumping to object.
All right.
Because an object is also a collection of values, but the difference between an object and an array, besides the fact that objects often have mixed data. When you think about doing like a call to an API on the internet, like give me some data from this other place, it often sends it back in this form called JSON or JSON or JavaScript object notation, which is generally some kind of value that's in those curly braces and then has a bunch of keys or properties that map to a value. So, for example, there you might say like, give me like I log into someplace and I talk to an authentication server and it authenticates me and now I'm on the site and it generally sends me back an object of data about my user. For example, like my name, when was the last time I logged in? What are my permissions? Do I have a user image of some sort? And that's often sent back in something that gets interpreted as an object and not an array, because arrays, I think by definition, are indexed by an integer. So the first element of an array is 0. Some programming languages might use 1 indexing, so the first one would be 1, but I would say the majority of them use 0 indexing, so they start with 0, right. And then the second element is 1, and the third element is 2, etc.
And
etc.
that all goes back to pointer arithmetic, right? Because it's how many of these things. It's my pointer is at the first element, which is I have to go 0 elements in to get to it.
That makes sense. I never
That's
thought about
where
that.
a lot of that comes from.
I never thought about that. It was just like imprinted onto me from an early programming age that 0 makes sense, 0 is correct, 1 is weird, don't do that, but that makes sense that would come from that. Whereas the object is, and also the array is in order. And that's an important thing. When you want to keep things in, the order matters. Whereas an object, the order sometimes matters, but in general, the object data type does not care about order. And these keys are not in any particular order. They are just properties of the data. And so, my name might come before my user pick, might become before my last login time, but it doesn't care, and I don't access its data in order. I access it by the key. I access it by give me my user object dot name, my user object dot last login, not my user object 0.
Exactly.
Yeah, and so that's why they're different, and that's what's unique about them. Although I turn objects into arrays constantly, and in JavaScript, the object dot keys and the object dot values method I use constantly to get just like the keys, and then I might want to put those in alphabetical order, or I might want to map or filter them by something. So they're unique, but they overlap quite a bit, and you go back and forth between them often. But what's your take on objects?
I will say, I want to talk specifically about the thing you were just talking about, which is an array of objects. Like going back and forth, like having an array of keys makes sense. Having an array of values makes sense. An array of objects always frustrates me because almost always what I want to do with that then is filter it based on the key, right? Or based on the value, which is the reason that people do that. I prefer objects of objects, right? So then I'm like, oh, the key is Dave, and then the value is Dave with some other, is first name, Dave, last name, Batista, right? Broll, I don't know. What Mustaine. I'm running out of Daves. Letterman. Right? And so like that's the way I tend to organize data tends to be key, and then I put that key also in the value. Whereas but that lets me have basically instant access to the data, just like you have in an array. I want the 5th element of this array.
Interesting that you chose that particular one.
Yeah, it's either boron or love, depends
right.
on who you
And the
talk
value of that key is obviously multipass.
Right. In an object, it's I want the name of this field. It's a field, right? It's I want the value that is stored at this key. And you could have key 1, 2, 3, 4, 5. Like you could have that. So instead of saying give me my array called elements sub 5, right, the 5th element in there, you could have an object of elements, and the keys for those could be the numbers 1, 2, 3, or a string of those, depending on the type of object it is. And then, so I could say, give me element. I say give me key 5 or the value for key 5 of from the object called elements, and that would give me back Leeloo Dallas multipass.
But why would you do that? Because that seems to defeat the purpose of objects.
It depends on what you want to store in them. Honestly, most of it's readability is what I would say. If you give me an array and it says Matt, and the next element is Messerman, and then the next element is 44, and the next element is 5, and the next element is 8, I have to know how to interpret that, and not. Whereas otherwise, I could say first name Matt, last name Messerman.
Oh, so you're
age 44.
You're explaining why objects are better. Okay, I thought you were going the other way. Yes, that is why objects are better.
Yeah. I'm saying you could do it the other way.
Yes, but why would you do that?
In both cases, you have instant access to.
Right.
You know, you don't have to iterate over it, because we when we talked about lists, we kind of glossed over this concept of a linked list, which was the way I first encountered lists, which do not have that property. You start at the beginning and you literally traipse through you have to iterate over it. You actually have to look at every value along the way, because you can't just jump because you don't know where it is in memory.
Right.
Who knows how these things are stored, but all that is abstracted away from us. And it's supposed to be instant access for all these things now.
You know, it seems like the perfect analog to that is it's like a linked list feels like a VHS tape.
Yeah.
And objects
As
are
opposed to a DVD.
Yeah, you just say no, just
Laserdisc.
Go to go to this part of the thing rather than start at the beginning and stop when I say.
go to chapter 4,
right,
as opposed to fast forward for 17 minutes.
Right.
Yeah. A similar concept to objects. There's a lot of them.
Yeah.
But an object, I think, most closely follows after what was in C more than anywhere else was what was called a struct, right? Which was just short for structure. And that was the main difference between an object and a structure is the structure was actually defining how the fields were broken up in memory, right? My struct is 2 ints and a float, right? And so in memory, I've got 32 bits for my first int, 32 bits for my second int, and however many bits floating point number is. A lot, usually. And then, but it's syntactic sugar to be able to say, okay, give me that by name X, as opposed to give me the first 4 bytes of this 19 byte or whatever. And so the structs came from there. And then you kind of take those concepts and there's a whole bunch of other names for similar things. There's hash maps, dictionaries, hash tables, which all have slight variations on them.
Yeah.
But ultimately, they're kind of the same thing.
Yeah, I think we're kind of working up to the big daddy of all of this, which I won't say yet because I don't want to spoil it. Although if you've programmed, you know what it is. But it's sort of like taking the primitive types and kind of adding them into like a super variable and then adding methods onto that. One of the things that I learned recently, once again about JavaScript, I'm a web programmer, I use it a lot, is that they have the concept of a map, which normally I just use that like I previously talked about as a filter or as a method on an array. What that basically means is like go to every element in this array and do something to each one. But there are map types, which are basically an object, but they also have built-in methods like get. So you can just say like, mymap.get a key, or you can say mymap.has and say, does my map have this value? Whereas you could do those with objects, but you would have to make those methods yourself. So a map is, once again, it's just syntactic sugar on top of an object, so you don't have to do that.
Yeah, a JavaScript map is almost exactly identical to a Python dictionary. Same idea. Yeah. And basically the way those work behind the scenes is you can put any key and any value into this object, and it finds it in, single order retrieval by hashing the value, which is why often these are just called hashes or hash maps. So basically, it converts the key, it uses some algorithm to deterministically decide where in memory that thing is going to go. So anytime you say, look for key ABCDEF, it converts it to the number 5 for whatever reason, right? And now it's always in the 5th memory location. You always know that for this object, it's going to be here.
Right.
But it's the nice built-in methods that really make that nice to have, like get and has and includes and
right. Well, and another just quick thing about the hash. Whenever I think of hash or hash maps, I think about it in terms of like you should make better passwords because there's these things called rainbow tables, which are essentially like it's just a 1-to-1 hash of like every password that's like under 10 or 12 characters and what it maps to so that someone could reverse engineer your weak password if you use something like that. And those tables can be searched much faster than like brute forcing every password that it could possibly be. And so that's a reason why you want to make long, complicated passwords so that it doesn't end up on an easily accessed hash map of that kind of thing.
Right. And there's a few things that are done that have been done to make that more difficult. One is it's only useful to use a rainbow table if you also have access to the encrypted passwords.
Right.
So that you can say, and effectively what a rainbow table is, it's a really slow brute force algorithm, right? You generate the brute force ahead of time, and then you're like, okay, there's that. And I look for your encrypted password in my hash table, and I'm like, aha, that's what it is, in my rainbow table. The other thing is, though, it's called salting. You have an additional value that is specific to your system or your program or whatever, that in addition to the key or your password or whatever, it includes both pieces of information so that a rainbow table is useless if you don't have the salt.
Right.
If you have a common salt or no salt, as it used to be, then your food is bland and your passwords are easily cracked.
Right. That's a very good point. You can also just mention enums, which is short for enumerations. I've barely ever used these. I mean, essentially what they are a collection of constants in one variable. So you could have an enum variable called direction, and it could have 4 values, which are north, east, south, and west. And in general, it's very useful if you want to give the user a choice, but you want it to be in a limited set, so not an unlimited set of potential things they could choose. So if it's not north, east, south, or west, then you know it's not a valid choice. But I don't know, Matt. It feels like it can be done other ways, and so I don't know. What's your experience with that?
I use them all the time. It's an efficiency thing, right? You can absolutely do this with like an object. You could have an object that has a key of north, and that gives you whatever information you need, right? The string north. But that requires you to store at least 5 bytes of data for the key, whereas if you only had one object, you only need 1 bit of to know which one you're doing, right? So it's basically it bounds the scope of what values can go into that variable, but it also means that you have human readable variable names,
right,
or human readable values that are stored in because the computer doesn't need to know north. The computer needs to know, change the location by -1 or something, right? But we don't want to have to read it that way. As humans, we want to. So enums are like a really good example of syntactic sugar. That's basically their entire purpose. But they are, when you don't use them, it's frequently because you're just not being efficient with your memory usage.
Right. Which, as a web programmer, I definitely am not efficient with my memory usage. Yeah, because as far as the computer is concerned, the direction is not northeast, southwest. It's just like 0, 1, 2, 3, right? But for us, we want to read north because north has meaning to us, whereas 0 does not have the same meaning and is harder to understand at a glance. So, yeah.
And most programming languages let you assign a value, a specific value to those things. So I might let's say I have let's like going with northeast southwest, I might have those effectively mapped to the strings northeast, south, and west behind the scenes, but I can use the enum for referring to them. And then what I can do is I could have a collection, I could have 100 directions. I could be the enum north, the enum east, the enum south, the enum west, and I could have a whole bunch of those together. And I only need that's 4, so like 2 bits for that. I only need 2 bits to represent those 4 values.
Right.
So I could pack a whole bunch of data into a small memory footprint and have it yield much more interesting data. It's shorthand.
That is a great way to define enum, and I may just cut out all the other stuff and put that in. Okay, the big grand boss of all of this complicated variable talk, I believe, all leads to the last type that we have to talk about. And as the resident OOP flag bearer here, I would give you the honors of introducing class.
Well, as a classy person myself, I love classes.
Quite.
Basically, a class at its core is adding methods to an object or a structure. Or when I learned classes the first time, literally they were like, okay, here's how a struct works in C. You can even add methods to a struct or functions to a struct, but it wasn't like ideal. And then there's classes, which is, oh, now I've got a struct and I'm putting methods in it and I've got a specific way of creating the class. I think the big difference between just a straight up struct with methods and a class is you've got a constructor for it, which is, here is how you initialize this object.
Right.
You give me this data and I will give you back this structure. Whereas otherwise you're populating it with like an object. You're like, okay, my object dot foo is this, or you curly braces and you define it, but you have to lay out all the fields. Whereas otherwise it's effectively a function call that gives you back this object that includes all of your data and the operations on that data.
Right.
So good example of a class, although we also called it a primitive type, is string, right? In C, string is an array of characters. In Python, it's a full-on class because you can do things like create a string and then say string.reverse, and it will give you the reverse of that because it's applying operations on the data that is within it, within itself. In Ruby, everything, even integers, are a class. You can do 5 dot times do this thing. I like classes a lot.
I like classes too, and it's a shame that I generally do most of my programming in JavaScript, and it doesn't have. Well, I will say now in like ES6, which just is short for ECMAScript, which is really what JavaScript is. It's like the 6th major version of it. Does have the concept of a class because I have made them, but for most of JavaScript's life, it didn't have the concept of a class, or at least not a first class notion of it. Yeah. It wasn't a first class citizen of the language, so if you were making a classes, you were basically hacking it, because JavaScript is a prototype language, and that prototype languages don't use classes, although they do now.
They're very similar in concept,
yeah.
But in execution, they're much more difficult to use, in my opinion.
Yeah, it is different, and it wasn't the way that, like I said, I mean, most of my programming concepts started with C and Java because that was what I learned in high school and college, and so JavaScript and even Ruby and stuff like that were very different. But yeah, if you want to do object-oriented programming, classes are very, they're the meat and potatoes. I wrote here a template for an object with methods and properties, because you define your classes by saying, here's the class name, here are its properties, it might have an integer x, integer y, here are its methods, here are the things you can do with its data. There's such a thing as a static class, which is different from the normal class, which normally when you create the template or the instruction set for your class, if you want to use the class, you have to make an instance of it. So you have to say something like, var foo equals new object or a new class. But you can also have things like in JavaScript, once again, there's the math class or module or whatever you want to call it. And you don't say new math object and then math.py. You just do math.py because there's, the concept of like, you don't need like each individual instance of math is always the same, and it doesn't have any properties that you change.
It has no data. It has no data,
right?
Object.
Yeah.
Except for things like pi, right? It has some constants baked into it.
Right.
But pi is always pi. It's always pi.
It's always pi, whether
the number
it's got
one does not change.
apple or peach. Yeah. Although I know there are some programming languages that might let you change what one means so that whenever you add one to something, it actually adds two. And that's the fun of playing with computers. Okay, so I think we've covered a lot of ground here. It's a lot to take in, I think, all of these different kinds of variables. Although I think, like I said, having a whole part one of this just on basic/primitive types, when the complex types that we've talked about in this episode are really just like kind of abstract collections of those things, helps to kind of narrow the scope really of how many different kinds of variable types there are. Most every variable you deal with is either going to be a number of some sort or a string of some sort, or the idea of whether it's true or false. I feel like, classes and structs and hashes and objects and arrays, they're just containers and structures that hold those things in them and allow you to do more complicated, interesting things with them. So as long as you get the basic ideas, you can build off of that to the more complex things. Does that sound right to you?
At a real high level, yeah.
Yeah. I mean, talking about the primitive types and going back to C and thinking about pointers and memory, and really, I think, in my mind, is bringing me back to like, how we got to all of these different kinds of complex types and why they work the way they do. And I mean, it's all dealing with memory in a computer. It's just, how do you deal with that memory? How do you refer to that memory? And how do you change what's in those memory addresses? And then these abstractions on top of it,
It all boils down to logical arithmetic.
Right.
It's all zeros and ones and turn them on and off based on ands and ors and whatnot.
Yeah.
And then just syntactic sugar all the way up.
It's yeah.
Or all the way down.
I didn't realize how sweet most of these things were, but I think I got to go see my dentist now because it's too much. Is there anything that you want to bring up that we haven't brought up already about all this, or does this basically cover it for you, Matt?
Oh, I could talk about all this stuff for hours. It's probably a good place to stop.
Okay. Okay, so I think that's our episode, part 2 of a 2-part deep dive, moderate dive into the different variable types that you deal with when you're programming, and the structures that that you deal with. I think we'll leave it there, and don't forget to check out part 1 if you didn't, where we went over the basic types. And if you want more episodes of this programming podcast, we may do more kind of moderate to deep dives on some of the fundamental concepts later. This was one I just wanted to try. Eventually, it seemed proper. But we have more episodes about other things on hackingthegrepson.com. And until we meet again, we now return you to your regularly scheduled lives already in progress.